Howdy, we are from the Department of Industrial and Systems Engineering. There are 4 people in our team: Reed, David, Eric, and me, Gia. We are doing a project called Cost Model for APS Plastics and Manufacturing. Before we get into the details of our project, I would like to give you a little bit more info on our sponsor. So APS Plastics and Manufacturing is a machining job shop in Tomball, Texas. They serve mainly to oil and gas industry. However, they have smaller clients in semiconductors, in aerospace, and even in medical sectors. 80% of their products are made of plastics. However, they do take orders that are made of metals like aluminum and bronze. A little bit behind their business activity, they incorporate a software called Paperless Parts, and it's essentially a software to interact with the customers, transforming customers' needs into products of a reasonable price. So paperless parts takes into account all the costs related to production. However, the one area that it has struggled with is estimating the time for the deburring process. With that said, our team came in and we were tasked with creating a new cost model for the project. This cost model would not only fit into the existing coding platform, but it would also need to accurately calculate for the time and money spent on hand deburring. Our team divided the project into different phases. We started out by looking into different sources of data. And after knowing about the trends and patterns, we tried to plug it into different models. These models would then be tested using the real production data provided by the company. The final and successful one would then be implemented onto their existing coding software. So now I'm going to hand it over to Cole so that he could discuss more about what we did for each different phase.
After thoroughly reviewing the problem statement, we were able to reduce the project into 3 phases. These phases allowed us to operate within a generalized framework when coming up with different approaches to satisfy the customer needs. First, we recognized the unavoidable need for data. Without data, we would not be able to form a mathematical relationship between features and deburring time, which would allow us to predict the cost in the future. Whether the data comes from previous scholarly research or a custom time study performed by us, we recognize this step as the foundation of our project. We lumped all efforts related towards data collection into the first phase, appropriately named data collection. Next, we boiled the issue of predicting future costs down to finding the relation between part features and deburring time. This can be thought of as a cost formula, as in, we plug in some parameters of the part's features, and the formula returns how much the part will cost to deburr. We reached out to professors in this field and learned the best way to do this is by using statistical learning techniques on our dataset from phase 1. All activities performed which contribute to finding the relation between time and features would be considered part of phase 2, model development. The last crucial element of the project was to integrate our work with current software used by APS Plastics and Manufacturing. We were put into contact with a representative of this software called Paperless Parts. The representative was able to set up an account for us, which would allow us to integrate the model developed in phase 2 with the current customer quoting interface. We established this area of the project as the third and final phase, integration. Regardless of the approach that we would take, we felt confident that we would produce quality work as long as these 3 phases were effectively addressed. Now that we've established a framework to work in, I'll hand it over to Eric to discuss the 3 approaches that we came up with.
In our first approach, we would address phase 1 by using already established data found by other scholars. Depending upon what we found, phase 2 would be completed by either using an accompanying model with the data or generating our own. In phase 3, we would manually hard code our results into our Paperless Parts account, yielding an integrated cost model as requested. In approach 2, we would perform a time study on a portion of an existing order to collect data for phase 1. With this data set, we would be able to use the statistical learning techniques to satisfy the second phase. Similarly to approach 1, we would manually code our results into our Paperless Parts account to integrate our efforts and deliver a finished product. To address Phase 1 in Approach 3, we would design a part which contained the features that APS Plastics and Manufacturing most commonly deburr. With the approval of our project sponsor, this part would be manufactured and allowed us to perform a time study on the deburring process. This way we could collect customized and accurate data. With this specialized data set, we could again use the same statistical learning techniques as in the first two approaches. After this, the model would be coded into paperless parts to address Phase 3. We decided to move forward with Approach 3. Although this approach would require the most resources and potentially create the most costs, we believe that the risk of this approach is much lower. This way, we may be able to calculate a cost estimation model for handy burring time that would be the most accurate.
Thanks, Eric. Unfortunately, due to the COVID-19 protocol put in place by the university, APS Plastics and Manufacturing, and the government, this project did not reach completion. The experiment design for the time study was never completed. However, the outcome of our efforts would make continuation of this project by another party seamless. In Phase 1, we reached a final part design after working with the company's programmer to implement features that would be representative of deburring challenges, while also keeping the required material and machining minimal. On the right side of the screen is the final CAD part. As you can see, it is dense with features including step holes, through holes, intersecting holes, counterbores, and various lips and slots. The plan was to manufacture 60 of these parts, 30 in the most common plastic machine and 30 in the second most common plastic machine. Then, the hand deburring employee would be filmed deburring each part. From that film, time-based data would be derived based on feature size, and material. Ideally, the data from Phase 1 would be used in Phase 2 to create a fully functioning model. However, without the data, there can be no model. After meeting with the faculty advisor, Dr. Don Smith, early on in the project, and conducting a literary search on the topic, it was decided that the model would be created using confidence intervals and a simple regression based on time values from Phase 1. Had the model been created, the final step was integration into paperless parts. We have a point of contact at Paperless Parts who had walked us through the interface and gave us the ability to play around using P3L, the programming language. The simplicity of the language and the pre-programmed functions, such as feature recognition, would have made this step the quickest of the three phases. That being said, with all the documentation and work that has already been done, it would be very easy for the project to be completed if acquired by someone else under more normal circumstances. The foundation for this project has been set and the framework has already been done. All it would take is a week of training and getting up to date on the project specs, and another team could pick back up starting with the time study. That wraps up this video presentation. Thanks for watching, and I hope you enjoyed our content. Have a great day.